All right, guys, let's look at our algebraic proofs foldable. Now this is kind of pieced together, kind of funky, and it's hard to put together, so we'll worry about putting it together at the end. We're just going to go through the pages right now, and like I said, we'll worry about putting it together at the end. I'll show you how to do it. All right, so the foldable should have the front that looks like this. It says algebraic proofs. Okay, so go ahead and cut out around the 2 pages. There's 2 pages front back to this. Go ahead and cut those out, and then we'll go over what we need to go over on it. All right, hopefully you've cut it out. All right, so over here on the right, these are the properties we're going to use with these proofs and in this packet. We are going to build upon this though. So these are the proofs we're going to use now. We will introduce more as we go, but we will continue to use these basic proofs. Okay, so if you turn to the back of page 2, you'll see examples that look like this. Okay, I'm going to go over a couple, and then I'm going to let you try to figure them out, and then we'll come back and we'll go over the answers. All right, so if we look at number 1, it says, if the measure of angle A equals the measure of angle B, and the measure of B equals the measure of angle C, then measure of A equals the measure of angle C. Well, we just did that algebraic foldable, and you should be able to get on there and look. Now, if 2 things are equal to the same thing, here, both angle A and angle C are equal to B, this would be the transitive property of equality. Okay, number 2, xy equals xy. Well, anything equals itself. This is the reflexive property of equality. Okay, 3, if 3x equals 6, then x equals 2. Well, how would we get from 3x equals 6 to x equals 2? Well, we could divide both sides by 3 to get x equals 2, so this would be the division property of equality. Okay, now if we look at number 4, if 2a equals bc, then ab equals 1/2 BC. Well, you can kind of do 2 things. We could either divide both sides by 2, that'd be division property of equality, but since we already used that, let's multiply both sides by 1/2. Remember, dividing by 2 and multiplying by 1/2 are the same thing. So we would get the multiplication property of equality. Okay, number 5, if 2 equals x, then x equals 2. What says that we can flip what's on each side of the equal sign? This would be symmetric. And I think I just misspelled that. I think it's only 1 t. Okay, 2 parentheses x plus 5 equals 2x plus 10. Well, here, all we're doing is distributing through. And then number 7, if AB plus BC equals 10 and BC equals 4, then AB plus 4 equals 10. We substituted 4 in for BC because they're the same, so this is the substitution. Okay, now I want you to go through and do 8 through 16, or try 8 through 16 on your own, and then we will go over the answers. All right, this is what you should have gotten for the right-hand column. If you missed some, that's okay. Just look at it and make sure you understand why you missed it or where you went wrong. All right, I know this is kind of out of order, and it's because it folds really, really awkwardly. But find this part here where we have the vocab part, and we're going to fill this out. All right, so a proof is a formal logical argument that shows or proves that a statement is true. Okay, 2-column proofs, which is what we're going to be doing here. It consists of two parts. It consists of the statement part and the reasons part. And it shows the logical order of an argument. So we're going in very sequential order right here. Okay, the statement part is always on the left column, and the reasons is on the right, and the justifications for each statement. So the reasons are the justifications, okay? It's why the left-hand side of the statement is true, and we'll do several examples so you understand that. All right, so let's look at this here. Right here on the left-hand side, notice this is an algebra problem that's already worked out for us, okay? So we're kind of going back to what properties did we use. So over here is the statements part, and over here is the reasons / justification part. All right, so 5x minus 18 equals 3x plus 2. Where the heck did that come from? Well, notice it's the same exact thing that's given here. So we will just write given. We know that's true because that's what we are given. All right, now when I look from line 1 to line 2, what I have to do is analyze this and see how did we go from 1 to 2? Okay, well, we subtracted 3x from both sides of the equation. Okay, and which property tells us that we can subtract the same thing from both sides of the equation? The subtraction property of equality tells us that. Okay, now we're going to look, how did we go from step 2 to step 3? Well, 2x minus 18 equals 2. Well, all we did is added 18 to both sides. So which property tells us we can add the same thing to both sides of the equation? That's the addition property of equality. Okay, and then from step 3 to step 4, all we do is divide both sides by 2. Division property of equality, and we get x equals 10. All right, let's look at another problem here. So 55x minus 3 times parentheses 9x plus 12 equals negative 24. All right, so once again, the left-hand side is all filled out for us. We need to fill out the right-hand side. So when I look from 1 to 2, actually, where did I get number 1? I skipped the gun here. We always start the same way. That is what is given to us. That's how we start the problem, is what's given. Okay, now how do we go from 1 to 2? Well, notice we got rid of the parentheses, and instead we got this. Well, all we did is we distributed this 3 throughout the parentheses. So this is the distribution, or distributive property of equality. All right. So how do we get from 2 to 3? Well, all I did is I combined like terms, so I didn't really use any properties, I just did math. So I'm going to put here simplify. Okay, now from 3 to 4, notice I got rid of this minus 36, so I added 36 to both sides. And what property tells us you could add the same thing to both sides of the equation? That is the addition property of equality. Now, how do we get from 4 to 5? Well, all we did is we divided both sides by 28. And the division property of equality tells us that we can divide both sides by the same thing and it'll remain equal. All right, so both of these we just did here are proofs. They're algebraic proofs, but they are proofs. And this is kind of the stepping stone. So we'll do 2 more. All right, here's our last 2 proofs. So what I want you to do is I want you to give this a pause, and I want you to try to work through these on your own, and then we'll come back and we'll go over them and I'll give you the answers. All right, guys, let's go over these last 2 here. All right, so our first step is always our given. Okay, and then from step 1 to 2, all we're doing is distributing through the parentheses, so distributive property of equality. From step 2 to step 3, we subtracted 10 from both sides of the equation, so we use the subtraction property of equality. And then we divided both sides by -5, which would be the division property of equality. All right, on the second proof here, We always start with what's given, comes straight from up top here. And then we subtract 7 from both sides of the equation, which is just the subtraction property of equality. Now, we subtracted 6x from both sides of the equation on number 2, so once again, that's a subtraction property of equality. So from step 3 to step 4, all we did is divided both sides by 2, so the division property of equality. And then I'm left with 6 equals x. I flip it around to x equals 6, which is just the symmetric property of equality.